Hello everybody, my name is Varunkrishna Kamala Govindaraju and I am here to demonstrate my pattern recognition project on detection of deformities in an integrated circuit using shape recognition technique. This project presents an idea of using shape recognition technique to detect the deformities in an integrated circuit. The idea of the project is to measure the shapes and dimensions of various stages of an integrated circuit and use the result to detect the abnormalities in fabrication process of an integrated circuit. Shape recognition is the process of automatic analysis of geometric shapes. The project emphasizes on shape recognition using techniques like computer vision, morphological operations, digital image processing, amongst others, and compare its performance against each other. The algorithm with maximum efficiency for our application of detection of deformities in an integrated circuit is proposed to be used to analyze the shapes of different stages of an integrated circuit and thereby detect the anomalies in an integrated circuit by evaluating the detected shapes against the design specifications. To give a brief introduction about the project, in pattern recognition, shape recognition is one of the significant research areas. Shape of an object plays an important role. The key information noticed by an eye on viewing an object is its shape and it remains constant irrespective of the color. Owing to its importance, shape recognition finds its application in several domains like robotics, fingerprint analysis, face recognition, etc. The idea of the project is to extend the application of shape recognition and thereby employ it to detect the deformities in a fabricated integrated circuit by recognizing its shape in various stages. In a computer system, shape of an object can be interpreted as a region encircled by an outline of the object. The most important aspect in shape recognition is to determine the exact shape information of an object. This project proposes to use shape recognition techniques to extract the exact shape information of various stages of an integrated circuit. Based on the extracted shape information, it is evaluated against the desired specifications, thereby extending the shape recognition technique to detect the deformities in an integrated circuit. To give a brief introduction about the shape recognition of an object can be achieved using two techniques. Number 1, area-based. Number 2, boundary-based. In area-based approach, the constituent pixels within the region enclosed by an image are considered to get the appropriate shape representation. That is, every pixel in the image is compared with the pixels of the actual predetermined image. Whereas, boundary-based technique captures the shape of an object by focusing on object boundary. While the area-based approach gives more detail about the object, boundary-based technique has the capability to represent the object shape feature more clearly than the area-based technique and is faster. Also, area-based technique is memory intensive. Hence, boundary-based shape recognition technique is proposed to be used for the purposes of a project. The principal idea of a project is to combine integrated circuit fabrication and shape recognition. Integrated circuit fabrication progresses through numerous stages. The design engineer, using the software, lays down the design of a certain integrated circuit. Based on design specifications, the circuit is fabricated. A fabricated circuit can have numerous flaws and hence should be verified. An example of integrated circuit flaw is non-alignment of successive layers of a wafer. This project proposes to recognize the shapes of various regions of an integrated circuit wafer using shape recognition technique and detect the flaws by comparing the recognized shape with the desired specifications. If the recognized shape matches with the desired specification, the IC is error-free. Else, the IC has a deformity. The project proposes to use two different algorithms and compare its performance. They are computer vision techniques and morphological operations. The algorithm with the best efficiency is proposed to be employed for the purpose of shape recognition and thereby extending the application to detect the deformities in an integrated circuit fabrication. To explain about the first algorithm, computer vision techniques. The proposed technique uses compactness of a region as a measure to detect the shape of an object. In this method, The algorithm recognizes the input image intensity, which is thresholded using Otsu's method to obtain a binary image. To detect the edges in an object, Sobel operator is employed, which is followed by thinning method to get away with unwanted edge pixels. Removal of unwanted edge pixels helps in increasing the efficiency of accurate shape detection of an object. Machine-based image processing has important applications in the field of pattern recognition. Computer vision is one such domain. An important subdivision of computer vision is machine vision, which has numerous applications including, but not limited to, inspection of semiconductor chips. Further, to minimize the human efforts of performing the machine vision operation, devices like input camera and image processing software are used to perform operations like shape detection, surface defect detection, amongst others. The following is the process flow of the proposed algorithm. The first one is the conversion of RGB to HSL. The input image in the RGB format is converted to hue, saturation and lightness, that is HSL color space. In the HSL color space, only the L value will be processed. The processed L component will be used as template to produce the final output by determining the shape. The significant advantage of processing only the lightness factor is the reduction in processing time and simplicity. The lightness value can be determined using the equation given in the slide. The maximum RGB is the maximum value of red, green and blue channel of input image, whereas the minimum RGB is the minimum value of red, green and blue channel of input image. The following slide gives a pictorial representation of RGB to HSL conversion. The second step is Otsu's threshold. After the conversion of RGB input image to L channel in HSL color space, Otsu's threshold technique is employed. The Otsu's threshold method automatically selects the threshold value using gray level histogram. To extract the required object from their background, suitable threshold of gray level histogram should be chosen. The significant advantage of Otsu's method is that it is an unsupervised method which automatically selects the threshold value for the segmentation of an image and it is non-parametric. Using the discriminant criterion, an optimum value of threshold is chosen. As a result, the separability of gray level classes are maximized. This process is achieved by using the zero and first order cumulative moments of the gray level histogram. The discriminant criteria used for Otsu's threshold process is represented in the equation below. To obtain an optimum threshold value, maximized value of lambda must be considered. The binary image obtained using Otsu's method visibly depicts the object and background. The pictorial representation is given in this slide. The third step is the image fill. The binary image obtained using Otsu's method might contain holes. Image fill is a technique to fill these holes, thereby eliminating the noise that might be present in the binary image. The fourth step is the median filtering. After the image fill process, median filtering technique is employed to reduce the salt and pepper noise and, more importantly, for the preservation of edges in the binary image. For performing the median filtering operation, a 10 x 10 matrix is chosen as the median filter operator. The process of median filtering is crucial for efficient shape recognition process, as detecting deformities in an integrated circuit involves high level of precision. The fifth step is the Sobel operator. Image processing and edge detection are the underlying concepts of the proposed algorithm. For efficient implementation of the algorithm, Sobel operator is used. Sobel operator is a discrete differentiation operator which is capable of computing the approximate gradient function of the image intensity. The operator at each point is a two-dimensional gradient which can be processed and viewed as an image by itself. As a result, the high gradient area are represented as white lines. In this technique, using Sobel mask, the outer edges of an image are detected. Once the outer edges are detected, the perimeter of the detected edge is calculated using the white pixels along the edge, which in turn gives the perimeter of the shape under consideration. The process of edge detection using Sobel operator is demonstrated in the figure below. The edges are formed by convolution of Sobel operators with the input image, resulting in a pixel value of 1. The pictorial representation is given in the slide. The sixth step is the thinning process. If the pixels detected are not in a straight line, it would result in increased pixel count. Therefore, by using the thinning technique, the pixels are arranged in a straight line. The last step is the shape recognition using compactness. This is the most important step in the proposed algorithm. After the process of thinning, the shape of the object under consideration is recognized by calculating the compactness given by the equation below. In the proposed method, square has compactness value ranging between 15 and 19, triangle has compactness value ranging between 20 and 40, and circle has compactness value ranging between 1 and 14. The following slide represents the output of a circle which is derived from the circle template. Similarly, the following slide represents the output of a square shape derived from the square template. Using the compactness value, templates of the shape are formed. Then, the templates formed are applied on the RGB input image to obtain the output image as shown above. On a concluding note, machine-based image processing has important applications in the field of pattern recognition. Computer vision is one such domain. The method of computer vision is employed to efficiently detect the shapes. Further, by employing techniques like image processing, human efforts are reduced. Owing to the accuracy and preciseness of this technique, the proposed method can be extended to detect the deformities in an integrated circuit by comparing the recognized shape with the desired shape, which can be stored in the database. The second algorithm proposed in the project is morphological operations. Morphological operations is one of the techniques that can be employed for the process of shape recognition. The issue enlightened in this case is over-segmentation dodging among different objects. The proposed algorithm has the capability to detect the shapes under following circumstances: A. When the image consists of distinct objects. B. When the given image has objects that are touching each other. C. When the given image has overlapping objects. And D. When the given image has an object which is contained in another object. In this technique, the focus is on recognizing the shape of an object by edge detection using morphological operations. The proposed method taking into account the over-segmentation problem among various objects. In the given image, objects are processed in an orderly fashion and the individual processed objects are clustered together to form the final output image. The processing of objects in a given image is executed in two stages.